Just a brief comment on the constrained inversion. I was talking to Christian about it just before we came back, and I just told him in a commercial world it's often very difficult because we don't really know what sort of, say a client's got an Excel spreadsheet of a bunch of MagSus data, but we don't really know how it was taken, how the fitness of the data. The spatial sampling is often an issue that we've only got the holes in the last 3 years, and all of the other ones that actually hit most of the ore body, we don't have any information. So then the applicability of it. But at the end of the day, one of the things I realized was there's not a lot of good case histories that showing that I've stood in front of so many audiences and said this is important, but I don't really have a reason from a point of view if a geologist were to spend the money or a project manager were to spend the money to get this, that he would or she would get very excited about the outcomes of a constrained inversion. It's sort of, some people will take a shot at it because it sounds interesting and they're prepared to try something new. But when you go to the literature, it's very difficult to find stories that aren't just sort of
There's some. There's 20 case histories in there.
Okay, all right.
So you can.
Are they all drillable after the fact? No, it's just.
So Ken, I've got a good point. So this came up in right. I don't want to get too much back. So if we're spending billions of dollars, and that's how much we do spend every year on geophysical surveys, how much are we spending on the petrophysical samples to constrain the result samples?
Nothing.
Nothing.
Yeah.
Nothing. And that is irresponsible, really. And we need to do better than that.
Well, it's like having a blood sample taken at the lab and then not having it analyzed. It's like you've gone to the painful part. You should at least get some knowledge.
Just take 2% out of your survey cost and get some petrophysical samples.
Yeah. Well, we're always here, so it's just it takes a long time to do. That's the unfortunate part. But I mean. That whole project was basically done with me and a few students and a mentor, John Walsh, and that was basically it. So you can do a lot of the groundwork with students.
So here's another one, right? So an organisation in Australia is about to spend $16 million on an AEM survey in our part of Australia, and they only have 2 petrophysical samples before they start their survey. 2.
Is it all undercover?
One's graphite, one's limestone. No, well, not to pick on Mike, but I mean, sometimes, we're capable of better behavior in industry, but we need somebody to sort of box us around the ears occasionally. And if governments were to say petrophysics should be included as, and one of the things like in Saskatchewan they've done with digital data is you get a premium on your assessment. Because the petrophysics, in a way, the dollar cost is just an annoyance. It's trivial compared with the primary data that you're trying to help work with and all the value-added work you're doing. But to come up with some creative way to say, if you do the petrophysics and file it with your other stuff that you normally do, you'll get our blessing, God's blessing, plus you get all these credits on your assessment. It's not going to work in most of the U.S. because they don't have any filing requirements, right? As was mentioned. Alaska and Nevada, pretty shocking. But where jurisdictions where some degree of sanity prevails, I think it may require actually a financial motivation to put that. Because the industry will, I think, do it, but they need to be pushed a little bit
Well, I don't know where to do it either.
Well, I mean, let the clients decide. Let the people doing the work on the ground decide. Where, if they're doing a mag survey or an airborne EM survey or gravity survey, I mean, there's enough geophysicists in the surveys now. They could say, hey, well, if you're doing a gravity survey, we'd really like to see some density measurements. Susceptibility, fine, but density, and if you're doing an EM survey, some connectivity.
What's the relevance of doing petrophysics if you're looking at weathered rocks? So,
well, if you got core, I mean,
if you have core,
has to
fine. But if you're doing the regional.
You're trying to get through that scuds. You're not worrying a lot, unless gravity, from the point of view of terrain corrections, you have to accommodate near surface effects, and gravity is probably the one that's most vulnerable to it, particularly if you're looking in the upper couple hundred meters. Mag doesn't care. EM will just crap out if you've got too much cover. Not a big problem in Canada in most places, but large parts of Australia it's an issue.
There's a lot of parts of Australia where we've got existing drilling connected to that.
Right.
So it's actually going back in, if you can go back to the time, then maybe somebody needs to go and do a new one.
Or go to a core library and start sort of working through those, because many states have those, and just start doing sampling. Anyways, sorry. Chris?
So,
Sorry.
no, sorry, I just wanted to follow up on what you said. In terms of the petrophysical data aspects, is there enough capacity outside of government to carry out those types of measurements on a regular basis? And if so, why isn't industry doing it at the same time?
We actually had a workshop on this a few years ago at the other SEG, and a couple of contractors, service companies that were totally capable of doing it, said we'd do it if it was enough work. We have the knowledge. You can buy good instruments, and GDD Quebec City makes a great set of gear for that. It's not the actual absence of equipment. There's no commercial traction basically there. And some companies like Zong and Tucson will do it, I think, because they support their own surveys. Yeah. They have an inherent curiosity that a lot of contractors don't have, because they're just data donkeys, right? They go and get your IP data or EM data. And it's not disparaging, but that's what they figure their role is. Whereas some groups just have enough problems that, a lot of people will send stuff there. Barrick, for the longest time, and I'm not sure if they still do, they maintained a Petra Physics lab at their Elko exploration office. Now, if no geophysicists in Elko anymore, I'm not sure, but they would hire like 2 or 3 students for the whole summer to basically run suites of samples. And I remember Barry Bourne, who was the chief geophysicist at one point, showed this plot of, it was several 100,000 samples from the Carlin Trend. And you got to believe that many samples, that there's some God's truth in that nobody else actually had. And they said that they regarded it as a competitive advantage, just to have that information, which is fine. As somebody said earlier, we don't need to worry about Matthew. There's certain boxes that companies are going to want to do for themselves, but by Barrick doing their own work doesn't mean anybody else can't do it. They probably buy the equipment at the same Radio Shack, for Pete's sake. It's just how they use it strategically internally and how consistent they are.
Ken, one of the comments I made this morning was sort of academia not knowing what industry knows, or students relearning what industry already knows. And one concern I have is when we make broad brush statements like industry doesn't collect petrophysics data. That's not true in all respects. Chemical collects a lot of petrophysics data. We've downhole resistivity, we've got mag sus meters, connectivity meters, sonic probes. So the problem is then universities hear that, oh, industry doesn't collect petrophysics, so they think that's the next bright thing to chase. Actually, a lot of us do collect a lot of petrophysics and do work with it. So I think we have to be really careful.
But I turn that around and say, if you are a light ahead of everybody else,
well, I don't know.
Then we sort of say, I don't say you have to have an obligation, but if you don't make academia aware of that, and you do it in isolation, then academia still doesn't know. Either people said they're not doing it, or people are doing it, but they're doing it in their closet. You can't really, so you don't really promulgate knowledge through, I still go to a fair number of geophysical talks, and the amount of decent petrophysics in there is thin, even in geophysical talks, let alone in any exploration context. So it's a very thin part of the business.
Yeah.
And
also, I would comment from the junior side that it's certainly the junior sector, which does really a lot of exploration. There's very little that's done, and all the geophysics basically it's all farmed out to service companies, et cetera, et cetera. And some of those guys, like Jeremy Britt, has a small petrophysical lab in his office. So he does a little bit of that, but he's not set up for any volume, not by any stretch. Not by any stretch. And doing petrophysical stuff in a lab, in a commercial lab, it's going to cost you a lot of money. Just doing density measurements is like cost you $15, just the density measurement. So it's like that stuff's not automated, right? It's all very.
That's why Barrick used students, I think.
Yeah, it's all very
a bit cheaper.
But certainly in terms of interpreting, I'm completely in agreement with the issue of the need of petrophysical physical rock property measurements to constrain and help you interpret the geophysical data and even geochemical data.
Well, I agree. I'm just
Yeah.
concerned
Yeah.
with the way we
Yeah.
relay the
No,
message.
generally, yeah. Well, I mean, the thing is, you're standing in front of an audience, and you say, oh, nobody's doing it except, oh, but that guy there is.
No, but what I meant was that it's may not be true for chemical or even tech, but how much exploration is being done by majors today, right? I mean, it's not a lot, right? I mean, it's like, and it's certainly true for the junior sector. It certainly is true for the junior sector.
And somebody mentioned Doug Oldenburg, rightly so, because he's generated a huge amount of intellectual property. To my knowledge, the only time that Doug ever had access to petrophysics was the work that Randy did for him on the Cleek-White-Cho kimberlite system. So Doug's been there at UBC since the 1980s, and I have followed him through his various reincarnations, various projects, and now it's GIP. That was the only project that I know they actually tried to look at petrophysics, and this is right at the end of his career, right? But finally, there was somebody, I guess there was a period after Jonathan Munafumbo left that there wasn't any sort of petrophysics at the GSC. Randy's out on the West Coast, on the Pacific Geoscience Center, right?
Yeah.
So he's one person. If you were to say, where could you get petrophysics done in Canada, there's probably 3 or 4 places that kind of do partial suites, and then I think Randy does a full-on set. But he's inside a government organization, so not really commercial in the sense that a lot of people would rather have, right? Because you can call him, like with James, you can chew his ass and say, hey, where's my stuff, right? Whereas a government person, it's not fair. It's not fair, Nick.
We don't work for you.
That's right.
No,
Anyways,
it's fair enough. And actually, that was part of my question back to you was, in the Footprints project, there was a lot of pressure back on us to provide Randy to support Footprints as the Footprints project, but Randy's also needed in government, so he has a job with us to deal with our programs and our needs, and so it was this real difficult balance.
Yeah,
and,
sure.
And I kept asking the question of where else people could go, and the answer kept getting back was nowhere else, nowhere else, nowhere else. And so from our standpoint, having it in a commercial sphere is actually preferable. It's even preferable for us, because then Randy can work on the difficult stuff, and the easier stuff can be out in the commercial sphere, kind of like geochem. So,
Well, one of the service guys at this workshop, just to give you perspective, somebody said, how much do you need a year? And he says, if I could see $100,000, I would set up a facility. $100,000, which in the scheme of things in a country that spends tens or hundreds of millions on these sorts of data sets, it is chump change, truly. So,
No, it's an important point.
sorry, one more comment for Dave.
Well, I just seeing both sides of it here. 'Cause I remember before I started my PhD, it took petrophysical measurements of every bit of core we ever drilled, and it was usually just mag sus and density. Then when I started my PhD and I wanted to do some modeling, and I went to dig up all the regional petrophysical data, Geoscience Australia had like a beautiful database with something like 200 samples for the whole country, and that was it. Luckily, most of them were in my area.
200
which is-
No, hang on, they've got 27,000.
Now.
Okay,
They have 27,000.
Okay.
Most of which are in New South Wales and Queensland and coal mines.
Well, there you go.
there you go.
But luckily, I was lucky they had the 10 in my data set. But the scary thing, we did just start, industry just started reporting all their petrophysical measurements, is I've definitely seen a lot of fieldies taking mag sus measurements of core in metal core trays and stuff like that, so there needs to be some sort of protocol.
No, definitely.
Yeah. But one of those problems does go back to, again, this thing, what happens to most of the majors have downsized out their teams, and obviously Canada hasn't. But had John McGahey, and he's done great papers, won awards for the works we were doing in core logging and petrophysical measurements. We did, there's a great one out where we did predictive modeling of the ore grades at the Kid Creek mine, and high resolution was incredibly good. And of course, because we were doing 3CD seismic, we had got the culture of doing it. So the problem was all that data is collected. And we go in assessment system, but that's kind of the nitty-picky stuff that doesn't get put in the database and never gets deposited. It's a nuisance. So what happens to data? I don't know when they shut down NTC where all the data kind of went to, right? So there was an incredible database created, because we did it, Michel did constrained inversions on the Equinox and deposit. And so we were doing them. The data's there somewhere, but you said it never sees the light of day. There isn't the, and then we go to the cheapest bid problem with contractors who, like you said, are taking gazillion measurements without any reference points. But they're in a market that's wanting the cheapest survey and need to turn around quickly. Well, if you're going to do it right, you got to go to the field, and there's a whole lot of effort to get the background data that's required to improve the quality of your work. And generally, this is more of a junior company, not the majors, but we're just, you got to get this thing done. I got an assessment report to do, and I needed drills coming in 2 months, so I got to have all my data turned around. This is an education issue, but they're really, when you start getting into those levels of understanding your data, everything's, well, as somebody said, they deliver a map, a mag map. The interpretation's separate. Doesn't even talk to the geologist. You outsource it and wait for the report to come in, and then it just hits it, and the geologist leans over and extracts the faults he agrees with and picks up the targets he likes, and the rest of the data, well, I don't like that, doesn't agree with my thinking. And that's a problem. It goes back to when you don't have teams, and unfortunately, as we've shifted more responsibility to the junior markets, they don't have the access nor the depth and the timelines to get into 3-year development projects and laying down the groundwork for a survey I'm going to do next year. It's a problem.
Yeah. All right. I think we'll good discussion. But let's finish. We've got 2 more talks to go.